refraction of light. Let's just start the topic refraction of light. How many of you have gone through the handout that I provided today? Anyone? Anyone? Yes or no?
No.
Okay. Refraction of light. Change in the path of a light ray as it passes from transparent medium to another. What I told that light ray, when passes through one medium to another medium, it changes its direction. Okay, either it. So this is the boundary. This is the boundary of researcher. This is your first medium, and this is your second medium. This light ray has, and this is the normal to it. Normal means the light which falls making 90 degree with the surface. Okay, so this is the normal, and this fine. So when a incident light falls on the surface, fine, and then it suffered a refraction. It suffers a refraction. Either it get diverted from the either it get diverted from the normal, or it come towards the normal. It depends whether the second medium is rarer or denser. If the second medium is rarer, then it will go away from the what? Normal. Okay? And if the second medium is denser, then it will go it will come towards the normal. Okay? Means if your second medium is denser, then the speed of light gets what? Slow down. Speed of light slows down. Okay? In the second medium, the speed of light will get slowed down. So it will bend towards the normal. It won't have enough energy to get far from the what? Normal. Okay, fine. So it will get towards the normal. It will go towards the normal. It will bend towards the normal. And if the medium is rarer, the second medium is rarer, then it will go away from the normal. Fine. So like this, incidentally, it has in the first case, the first medium is rarer and the second medium is denser. So it has gone what? Towards the normal. Okay. The incident ray after refraction went towards the normal, and here in this the incident ray after refraction went went away from the normal. Fine, away from the normal. Why? Because this first medium is the denser medium, and the second medium is the rarer medium. So the energy of the light increases, the velocity of the light increases. This is why it went away from the normal. Fine. Change in the path of light ray as it passes from transparent medium to another. And as it passes from one transparent medium to another transparent medium is called refraction of light. When light ray travels from a rarer medium to a denser medium, it bends towards the normal. It means that angle of incidence will be greater than angle of refraction. Here in this, it bends towards the normal. Here in this, angle of incidence I is greater than R. Right? Here I is greater than R. And in this, the R has got extended. Means I is less than R in this case, when the second medium is rarer. Okay? Fine. Any problem? I is called the angle of incidence, and the R is denoted as the angle of refraction. Okay? Cause of refraction, why the light gets refracted? As already that I discussed before, the speed of light is different for different media, because light bends towards the the speed of light is different for different media. It will be larger in rarer medium. If the medium is rarer, then the speed of light will be larger. Okay, or you say more, fine. And if the what I'm written here, if the medium is denser, then the speed of light
Ma'am, it will be speed of light will decrease.
Speed of light is low. Okay, so this is why when the light comes from rarer medium to denser medium, it experiences refraction, because it bends either away from the normal, right? Or towards the normal, either away from the normal or towards the normal. This is your normal. Fine, either away from the normal or towards the normal. More in rarer medium, comparatively less in denser medium. So when light enters a denser medium, its speed reduces and it bends towards the normal. And when it enters rarer medium, rarer and denser, by rarer and denser, are you getting or not?
Yes, ma'am, getting it. Ma'am, rarer means the medium which is light, and denser means the medium which is more thick.
Density, thick, yes. These more particles are there, like air is the air is the rarer medium, and what? And a glass slab is the denser medium. Okay.
Water
Rushil, can you please
water
switch
is
on your
also.
camera?
Yes,
Water
ma'am.
is also denser medium. Can everyone switch on
Yes,
their
ma'am.
camera? Rudra, it's already 13 minutes and you haven't switched on your camera. I can see your cupboard or something like.
Actually, my camera stand is broken.
Yes?
My camera stand is broken, so I can't.
Okay. Okay. Examples of refraction of light. The bottom of pool or tank or pond containing water appears to be raised due to reflection of light. Examples like we'll see the example of reflection of light. Like if you will take a pen, fine, take a pen and put it in a glass of water. Okay. So what you'll see, if you will if you will take a pen and put it in the glass of water, okay. So what you'll see, isn't it? If you have if you if you have put the this your pen like in 90 degrees, then you won't see any kind of reflection. You can just see your pen has got a little bit thick inside the water, right? And if you will insert your pen like making a degree, making an angle with the water surface, then you'll see that your pen has got bent to a limit. You will see you'll clearly see that your pen has got bent. Fine. Just after the water level, just after the what your second medium starts, you'll see that your pen has got bent towards the normal. Okay, why? Because the pen has gone from which medium to which medium? From rarer medium to denser medium. Okay, from rarer medium to denser medium. So it will become what? So the speed of light will slow down, and what? And the your pen will look look like as if it has got bent towards the normal. Okay, like see the bottom of a pool or tank or pond containing water appears to be raised due to refraction of light, which take place when light rays pass from pool of water into the air. The bottom of the pool or tank containing water appears to be raised due to, means if you see the surface of the pool after water, then it will look like that it has got raised to a certain height. Okay, so this is all because of
Rarer to denser.
rarer to denser medium. Okay, refraction. The latter appear to be raised when viewed through a glass slab placed over the document. Like if you are placing a glass slab on your book, then you will see that your paper the letters of that book will be raised, will look like that it has got raised to a certain height. It will be just because of the refraction. Okay, a pencil partially immersed in water, like what I told you just now, as the first example, that a pen has, if you immerse a pen in water, then it will appear to be bent because the refraction of light coming from the part of pencil that is immersed inside water. A lemon kept in water in a glass tumbler appears to be bigger than its actual size when viewed from its size. Okay, so lemon also, when you will keep it inside the water of a water inside a glass tumbler, then it will become it will seem it, you'll see it will appear to be a bigger size than its actual size. Okay, so it's all because of these are all because of the refraction. Refraction through a rectangular glass slab. Refraction through a rectangular glass slab. Now you see the rectangular glass slab. Say how the light gets refracted. Okay, now here you'll see this is your normal. This is your normal. Okay, This is your normal because this is 90 degree with the surface of the with the boundary of the two surface with the boundary of the two medium. Okay. Now incident light is falling on it. Fine. Incident light is falling. Arrow is important, and then it must go like this. It must go in a straight line, right? But it will not go in a straight line because it will suffer refraction. It will suffer refraction, so it will bend towards the normal like this. This is called your refracted ray. This is called your refracted ray. Okay. And then again it comes. This is your first medium. This is your second medium, and this is your first medium again because this is air again. So so what will happen? It's now coming from second medium to first medium, which is from denser to this. This is your denser. This is your rarer again, and then it will the ray will emerge. The ray will emerge how? Because this medium is and this medium is equal, right? These are same medium, first and the third medium. Like if you see this medium and this medium are the same, right? These both are air. So when it will get after refraction, it suffer refraction. Fine, again it will suffer refraction. In this case, it will now this is your normal. Okay, now this is your normal between these two medium, and when it will emerge from this glass slab, the ray when the ray will emerge from the glass slab, it will bend away from the normal. Why? Because it it is going from denser medium to rarer medium, and you'll see the emergent ray will be parallel to the incident ray. Why? Because this medium and this medium is same. Okay, this is same medium, this is same medium, this medium and this medium. Both of these medium are can be taken as first medium, and this is your second medium. This is your rarer medium. So this incident ray and emergent ray and this incident ray will be parallel to each other. Fine, because it will emerge and as same as that of incident ray. Incident ray was falling upon the surface, and emergent ray will emerge from the surface in the same fashion as incident ray got. Fine. Fine. Is it fine or not? Okay. So this is your incident ray. This is your incident ray. The angle between the incident ray and the emergent ray is called the RE, angle of incidence. The angle between normal and the refracted ray is called what? R, which is called the angle of refraction. The angle between this refracted ray and this normal again is called this R. And then the angle between the emergent ray and the normal will be called as E. Will be called as E. Fine. Okay, is it fine? Now this is very important thing. This is your lateral displacement data. How much the image has got displaced means it actually it hasn't got displaced, but when we'll see that image should be somewhere, but it's appearing somewhere else. Like the image would be here, but to us it's appearing as if the image is here at this point. Fine. This is called your what? This is called lateral displacement. The displacement of the distance between your emergent ray and the incident ray. The perpendicular distance between the emergent ray and the incident ray. This is your incident ray and this is your emergent ray. The perpendicular distance between these two rays is called the lateral displacement. Is it fine? We also have formula for the lateral displacement. Okay, it's in the ICSE board given lateral displacement formula. Okay, so lateral displacement formula is, Rishil, are you there?
Yes, ma'am.
Okay, so the formula for the lateral displacement is T sine I minus R upon cos R. This we can very easily derive this formula very easily by using the Pythagoras theorem and some of the lines and angles. Okay, so
Excuse me, ma'am. I was having doubt in some of the assignments for both class 9 and 10. So, after the class, can you actually clear it? So, 2 minutes.
Actually, I don't have time for that. I'm sorry.
Ma'am, so may I send the questions afterwards?
You You said if I will be I will have in time, I will tell you. If
Okay,
not,
ma'am. Then I'll try to do it by myself.
okay. So what I was telling, the lateral displacement formula, how we are going to derive lateral displacement formula. Actually, in exam we don't need to derive it, but still we must know that how it's getting derived. So you see, let me take this here. See, just extend it. This is also now your 90 degree. Okay, this is your 90 degree. Now you have to calculate the value for L. Means this is same as this, right? Am I correct? Aren't these the same? Yes or no?
Yes, ma'am.
Right? These are same. Lateral displacement. This is also L. So we'll calculate this and we'll find lateral displacement. So how to calculate it? This is 90 degree. This is 90 degree. Okay. This is also let name these points. Let this be A. This point, okay, A. This point as B. This point as C, and then this point as D. Fine. We have two. We have two triangles, that is 90 right angle triangle. Okay, from these two triangles, we'll derive the formula for lateral displacement. This. Okay. Now we'll see for triangle ABC. For triangle ABC, you can see the triangle ABC now. Angle for triangle ABC, angle B is what? You'll see this. If you are going to draw like this, this is your one line. This is your one line, and this is your one line. Okay. Are these and this whole is making this and this is making vertically opposite angle? Yes or no? Say yes or no.
But ma'am.
These two angles are vertically opposite angles or not?
Yes, ma'am.
Right? Roshin, Rudra, getting how these two angles are making vertically opposite angles?
Yes, ma'am.
Okay. So don't say only yes. If you have got problem, please let me know. Okay. So this will be your eye. Means this is your eye, and this whole will also be your eye. Okay. This whole will be your eye. But it's given that this angle is R. So the remaining angle will be how much? This angle will be how much? I minus R. Will it be? It means I'm saying now you have got this point that these two angles are making 90 vertically opposite angle.
Yes,
so this angle will be I minus R. Let me write it clearly.
Okay.
This angle will be your this I minus R, because this is I and this is I. Okay, fine. This is I and this is I. Okay, this is I and this is I. So, but this is R. Okay, this is R. So how much it will be? It will be how much? The rest I minus R. Is it okay? If you take out this part, it will be like this, somewhat like this. This and this. Okay, and one more thing is there in between this. Okay, so this is your I. Okay, this is your I. This will also be your I. Yes? Yes, now?
Ma'am, why it will be I? Why it's not R?
No, this whole is I. This
Okay.
whole is I. And natural, this is your R.
Okay,
This
ma'am.
is your R, no? This is your R, right? This whole is your I. This whole is your I means this whole is your I. Can you see my pointer? This whole is your I. This much is your R. Then how much it will be? This angle, the rest angle. This angle. I minus R or not? It's so simple, now. It's so simple, now.
Oh, ma'am, I got it.
You have got this. This is your I. This will also be your I. Okay, the whole I. But now you have divided it into two parts. Divided it into two parts. This of which this one is R. Then how much it will be? How much it will be? I minus R. The whole is I and R has got reduced from this. So what is remaining? I minus R. This is what I written here, I minus R. Okay? I minus R. B, A, B. This was your B now. I wrote B. Fine now. Fine now. Now, we'll see what is here sine I minus R. We'll see what is sine I minus R from triangle which ABC. Sine I minus R. What is sine I minus R? What is sine? Are you knowing this or not? The sine and cos? Rushil and
Yes.
Rudra?
Yes, ma'am. But
Trigonometric ratios? Safia, are you knowing about sine and cos? Yes or no? I can't listen you. What did you say? No or yes?
ma'am, she said no.
Okay. And Rudra, are you knowing about sine and cos? Trigonometric function?
Yes, ma'am. We finished the chapter.
Somewhat you okay, fine. Rushil, are you knowing?
Yes, ma'am.
Okay. Let me tell you, Safia, sine, these are the trigonometric ratios, sine, cos, tan, sine, cos, tan. It is used in this your what we say right angle triangle. Sine for sine in short I will tell you in short I just will tell you this you will study it in class 10 only. Ma'am will teach you this trigonometric identities and introduction to trigonometry, something like chapter is there. So sine is, this is your perpendicular, this is your base, this is your hypotenuse, right? So sine is nothing but sine theta is nothing but if this is theta, then this will be considered as perpendicular. So the formula for sine theta is P by H, perpendicular by height. Okay? And for cos theta, it is B by H, base by height. So this is your base. Wherever the theta is given, the side adjacent to the theta is considered as base. Okay? So cos theta is equal to B by H. So this will be your B and this will be your H. It will be B by H. So considering this sine theta P by H, can we write this sine I minus R? What will be the sine I minus R? Here for triangle ABC, sine I minus R. What will be that? Will it be your perpendicular is L for theta I minus R? For I minus R, perpendicular is the opposite angle, opposite side to the theta, right? It will be what? L upon what? Hypotenuse. And hypotenuse is what? Hypotenuse is this, your AB. AB is your hypotenuse. So you can write it like AB is equal to L upon sine I minus R. Okay? AB is equal to L upon sine I minus R. Fine. Now we'll see in this triangle, in triangle this ADB, or you say ABD. Okay, we'll see here cos R is equal to, and yes, one more thing, that BD is your thickness. BD is the thickness of the glass slab. This is BD up to BD. This all BD is the thickness of the glass slab. Okay, so it will be considered as T. Cos what? Cos R is equal to, this is your R. Okay, this angle is your R. So cos R is equal to T by what? T by hypotenuse. Hypotenuse is what? BA means AD. AB. Now from this also we have got AB is equal to T upon cos R. Now these two, first equation and second equation, equating these two equations, because here also it's AB, here also it's AB. So equating these two equations, equating 1 and 2, we'll get what? T upon cos R is equal to L upon sine I minus R, of which we want what? L. We all need L, right? The lateral displacement will be, now we'll take this sine I minus R to this side, T sine I minus R upon cos R. This is what we want as lateral displacement. T sine I minus R upon cos R. T is the thickness of the glass block. Okay, got it? What is the lateral displacement? Fine. How we are going to derive this lateral displacement? Just using the two right angle triangle. Fine. Lateral displacement depends upon the following factors. What is the lateral displacement depends
I
upon?
didn't
Yes.
understand
What you didn't understand?
how to derive lateral displacement.
If you see, it's very easy. You just need one for this sine I minus R and for this cos R. All you need these two things, and you are knowing well about the formula for sine sine theta and cos theta, that it will be PYH and it will be BYH. You just need to put the values what you have done here. L upon AB. Just simply L. This is your perpendicular. Obviously, the side opposite to the theta is perpendicular for the right. It's the perpendicular. So sine I minus R for sine we take perpendicular. We'll take L and L. This is this will be your hypotenuse because this is your perpendicular. So sorry, this is your base and this is your hypotenuse. So this we'll do what L upon BA. From both we'll get the value for AB and we'll equate both of them. One time cos and one time sine. Fine.
Yes, ma'am.
You just take this as extra information because this is not actually in your course. Fine. So in CPSC this is not there, but still it should be in your knowledge that how it's getting derived. And also in ICSC there is formula but not the derivation. I just told it in extra. Fine. So just you need to know that how it will get derived. It's also get fine. Okay. Lateral displacement depends upon the following factors: thickness of the glass block, lateral displacement. How whatever be the thickness. Obviously, lateral displacement here it is depending on thickness. The formula itself is telling it is dependent on T. Okay, T, and then angle of incidence. Obviously, angle of incidence because in the formula there is angle of incidence. And refractive index of the glass. Refractive index is what? This is your mu. Mu is the refractive index. We will study this refractive index. Fine. Refractive index of the glass means these three factors the lateral displacement depends. Refractive index, while refractive index it is depending on refractive index because refractive index only tells whether what will be your angle of refraction, because here it's depending on angle of refraction also now. So angle of refraction will not, instead of mentioning here that it's depend on the angle of refraction, because angle of refraction itself depends on something, which is what? Which is refractive index. Fine. So are you getting my point? Refractive because angle of refraction itself is getting dependent on refractive index. This is why it has directly written that this lateral displacement is dependent on refractive index, not angle of refraction, because it will depend on refractive whatever the refractive index. The angle of refraction will be accordingly. Okay, is it fine?
Yes, ma'am.
The ray of light is incident at an angle of 45 degree. So you have got I is equal to 45 degree. Okay, I is equal to 45 degree. On one face for rectangular slab of thickness T you are given 10 centimeter. T you are given 10 centimeter. And refractive index is 1.5. And your refractive index is 1.5. Okay. I mean, we'll study what is the formula for refractive index. Here it's given in the law of refraction that when we will study the laws of refraction, sin I by sin I is equal to mu. Then we will solve this question. Just okay, fine. Let it be like that. We'll solve this question after studying about the refractive index, so that you'll get clearly that what to do in this by this formula, because this is the formula we haven't studied with. Now, mu is equal to sin I by sin I. So let this be. We will study. We will do this example later on. Okay. Law of refraction. Lateral displacement that we have already studied, and then law of refraction. So there are again two laws of refraction. Likewise, we studied two laws of reflection, right? Two laws of reflection. One was what? First law of refraction was, law of reflection was what? Joseph, can you tell me? Joseph, can you tell me the law of reflection? First law of reflection.
I is equal to R.
Yes. No. I is equal to R is the second law of reflection. First law.
They all lie on the same plane. The incident ray.
They all lie in the incident ray, the normal ray, and the reflected ray. They all lie in the same plane and at the point of incidence. Right? The same is the angle of refraction. The first law of refraction. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. This is same. Fine. First law of reflection. The first law of refraction is same as that of the first law of reflection. Now the second law of refraction is Snell's law, which tells that the ratio of sine of angle of incidence to the sine of angle of refraction for light of given color is constant for a given pair of media, which is equal to what? Which is called refractive index. Means the refractive index is nothing but the what? The sine of angle of the ratio of sine of angle of incidence to the sine of angle of refraction. This is your refractive index of that medium. Fine. This is sine of angle of I to the sine of angle of R. The ratio is equal to some constant. That constant is named as what? Refractive index. Okay? That constant is known as refractive index, which is denoted by mu. Okay? Refractive index is something like the extent of the change in direction of a light ray that takes place in a given pair of media is expressed in terms of refractive index. Is how much the light gets refracted in coming from first medium to second medium. How much the light ray is refracted. Okay, to what extent the light ray is getting refracted. This depends on the refractive index of the medium. The more the denser will be the medium. The more the denser, mu will be denser. More denser, so more refractive index. More will be the refractive index. More will be the dense medium, more will be the refractive index, and less will be the less the denser medium, and less will be the mu. Mu will be what? Small. Mu means refractive index will be small. Okay, fine. So we also study some more example of refractive index. Okay, the extent of the change in direction of ray of light that takes place in a given pair of medias is expressed in terms of refractive index. This represents what, this represents like mu2 and 1. Either you can write here also 1 and you can write here also. This is called refractive index mu of second medium with respect to first medium. Okay, mu of second medium is refractive index of second medium with respect to first medium. Okay, this is denoted as this. Means whatever be the here it depends. Here it represents the number here. The number here or just after the mu will represent key of which medium the refractive index is given, and here it represents that with respect to which medium the refractive index is given. Okay, so if you are going to write this refractive index of medium 2 with respect to 1, actually the formula for this is refractive index of medium 2 upon refractive index of medium 1. This is the formula for refractive index of medium 2 with respect to refractive index of medium 1. Okay, mu 2 by mu 1. Now we see like here, see. Here we'll see the refractive index of glass with respect to water. Okay, refractive index of glass with respect to water. What will be the refractive index of glass with respect to the refractive index of water with respect to the water? Okay, so what we have to write? Refractive index of glass will be written in the numerator. Refractive index of glass. Here we'll write the refractive index of glass with respect to air upon refractive index of water with respect to air. Here we will write, this we have to write. Okay, what will be the refractive index of glass with respect to water? So it will be refractive index of glass if of whatever you will be finding the refractive index, it will be written on the numerator. Refractive index of glass with respect to air now. Okay, you can not even write anything, but still you will write A so that it will be clear that you with respect to what you are finding the refractive index. Fine. Refractive index of glass upon refractive index of water. Okay, you can skip this. Okay, fine. You will write in this way. Like I wrote refractive index of 2 with respect to 1, so it will be written on numerator. You can get confused whether which one is to be written in numerator and which one is to be written in denominator once you will study one more formula for the velocity. So this is why I'm saying that don't get confused between what we have to write is in the numerator what refractive index of which medium is to be written. Refractive index of the medium to be written in the numerator is of the medium that we are calculating for. And in the denominator, it's written the refractive index of that medium is written with respect to which medium we are calculating. Okay, so 2 right side, if 2 is in the right side, then 2 will be in the numerator. Right side,
Understood.
Right side numerator, and left
So
side.
the one in the right side will be in the numerator, and the one will be on the left side will be denominator.
Yes, the right side will be in the numerator, and now it will get reversed while if we will talk about the velocity because velocity is the opposite of the refractive index. More the refractive index of the medium will be, the less will be the velocity. So it will get reverse. Just it will get reverse. Okay, because more the refractive index will be, more it will get refracted. Means more it will bend towards the normal. More the refractive index of the medium will be. It means that if it is bending towards the normal, it means that the velocity of the medium is velocity of the light is getting decreased. Okay, so the refractive index, the velocity of light is inversely proportional to the refractive index. Fine.
Yes, ma'am.
Now, yes.
Light goes into more dense material.
I cannot
Ma'am,
listen
can you
to
show this refractive index and speed of light?
Yes.
Yes, this one only. I want to just take a screenshot.
Yeah. You don't need now to take the screenshot. I will send now. I already have sent it as a handout.
Oh yeah.
Which 2 cases, Safia?
Ma'am, may I leave? I have another class.
Yes, you leave. Just I'm also leaving for the this message is coming. The time is getting up now. So we'll study with the light with the speed of light in the next class. Fine. Okay. So we'll complete this topic in the next class and then we'll start lens. Okay. So bye. Yes. Yes, Safia. So then we can read.
Explain that how the speed of light will change.
How the speed of what you,
Yeah, if it goes into a more dense material, then the speed will decrease.
yes, the speed of light decreases.
And
We will study now when we will study these formulas now. Then we will come to know about means then we'll like so what is the speed of light in diamond light? Okay, so there is the examples now. So we'll study when we will study this formula and then we will do this example. Then you'll come to know that how it's getting decreased. Okay, fine. Okay, so bye for today.